Hi, this is Madhura Sridhar, and this is my digital forensics final project. It's titled Web Traffic Analysis by Packet Level Feature Extraction. So, web traffic is home to many different types of traffic and information, and most of the traffic that constitutes the web interface uh, is made up of the TCP/IP infrastructure. So, the popular protocols that can be found very commonly in web traffic are HTTP, which stands for the Hypertext Transfer Protocol, and that enables communication and connection between the client and a remote or a local web server. And secondly, it's the DHCP protocol, which is the Dynamic Host Configuration Protocol. And this is a protocol that is responsible for assigning dynamic IP addresses and other configuration related information to one or more clients. And thirdly, it's the DNS protocol, which stands for Domain Name Service. And this protocol is responsible for the domain name to the IP address resolution. And fourthly, it's the SMTP protocol, which stands for Simple Mail Transfer Protocol. And this protocol is responsible for transferring emails and also for communication between two or more parties through a mail server. So the project methodology is such that I've aimed to perform packet level analysis of PCAP files that I've captured from different online sources that I'll be talking about later through the presentation. And I've analyzed each of the packet PCAP files and the packets manually first on Wireshark to create an outline of anomalies. And along with that, I've also developed Python scripts using a module called PyShark, which is Wireshark like, but it helps in parsing PCAP files in the Python programming language. And I've used PyShark for feature extraction, and using the features that are extracted from different PCAP files, I've later constructed the anomaly strategy that is used for detecting anomalous packets in different PCAP files based on the features that are extracted. Yeah, so most of these anomalies are classified as per the protocol. So they're protocol dependent and protocol specific. And when a particular packet is anomalous based on the classification, the detection mechanism is invoked. So firstly, let's look at HTTP based anomaly detection. So I've classified four different types of attacks and detection strategies that are possible from the PCAP files and the dataset that I've studied over for the project. So firstly, it's the packet injection attack, wherein a single HTTP request sent by a client receives more than two uh, responses from the server with the request number and the response number mismatch. And secondly, it's the redirection attack by man in the middle or man in the side, wherein there's more than one redirection to any client HTTP request that is sent to the server. And thirdly, it's the email phishing attack, wherein user is duped to and redirected to a particular URL that is malicious, and he's made to submit certain sensitive and private information like user ID, password, and credit card numbers, and so on. As the email claims to be from a certain point of origin that looks, to be trusted, and hence, it's like a dupe based attack that the user is pushed into. And fourthly, I've done the port confirmation analysis to check if HTTP traffic is on the standard port of 80, which is the port on which the HTTP traffic resides. So let's look at analyzing the programs and also by running the program. So this is a program that I've written for performing HTTP level protocol analysis and anomaly detection. So firstly, I'm checking for the request number and the response number, and if there is a mismatch between the request number and the response number, then it could be a potential injection attack, as I've already told. And I'm also checking for more than one redirection that is sent by the server to the client request. And if that is the case, then again I've detected that there could be a possible HTTP based redirection attack. And thirdly, if the browser seems to be sloppy by not responding to any of the client requests, then I've detected that particular scenario as well. And fourthly, I've performed the port confirmation task by checking for and analyzing the source and the destination ports of HTTP traffic, which needs to be 80 in the most standard scenario. So now let's execute the program and perform some HTTP level protocol analysis. So I need to enter the PCAP file that needs to be analyzed. So the detection report for this particular PCAP file is HTTP based redirection attack is possible because there's more than one redirection to the same request sent by the client, and the possibly anomalous packets are 6 and 14, and HTTP port conformance is done and no issues are found. So that's about the HTTP analysis for this particular PCAP file. Let's look at another PCAP file. So this PCAP file is found to be safe from all sorts of HTTP anomalies that we have classified and formalized. So that's about this PCAP file. Now looking at another PCAP file. So here the browser is found to not respond to any of the client requests, and that detection is again made, and HTTP port conformance is done, and HTTP traffic is found to be residing on the standard port of port 80. So that's about this packet. Now going on to the application of HTTP based anomaly detection, I've taken a particular scenario wherein a user gets a mail that it's from target.com, which is a famous clothing and a multi-speciality sort of an organization and company. So and the user is made to click on a particular link, and that link is found to be malicious because it doesn't belong to the domain name of target. So that just confirms that it is a possible case of email phishing, wherein the user is duped to click on a certain link since it came from a certain claimed source of trusted origin. And we can confirm this by looking at the Wireshark capture for that particular PCAP file. Okay, it's taking some time to load. So let's look at executing the program. So this is the PCAP file that is captured when that particular user logs into or clicks on the link that is embedded in the email. So I need to enter the PCAP file that I want to analyze. So here I also need to enter the company from which the mail claimed to be from. So in this case it's Target. So the conclusion is that it is a possible phishing attack, and this is because when we examine the HTTP request and the response URI of the PCAP file, when the user logs into that particular link, it's found that it doesn't belong or contain the domain name of the claimed source of origin, which is target.com. So this confirms that it is a potential case of email phishing attack. So that's about the application of the HTTP layer anomaly detection. Now moving on to DHCP related anomalies. So here again, PCAP files are analyzed for anomalies in the DHCP protocol, and the file name option is checked for overloading, and the server name option is again checked for being overloaded, and the DHCP is again checked for all the end options, and if the end options are missing, then a possible alert is again detected and given to the user, and the denial of service attack is checked if the DHCP lifecycle is incomplete. So DHCP protocol contains 4 different types of messages and stages. So the first one is DHCP discover message, and the second one is the DHCP offer message, third one is the DHCP request message, and the fourth one is the DHCP acknowledge message. So if all these 4 different stages are present in a PCAP file, then that means that the DHCP lifecycle is complete, and if not, then the DHCP lifecycle is incomplete, and potential denial of service attack is detected and signaled. And fourthly, port conformance is again done to check if DHCP is residing on the standard ports of 67 and 68. So let's execute the DHCP based analysis and anomaly detection for this packet. So it's found that the DHCP file and server options aren't overloaded, and DHCP traffic is found to be on standard ports. So this packet is fine. So this PCAP is fine. So secondly, let's look at another PCAP file and analyze it for DHCP protocol. So here the DHCP lifecycle is again found to be complete, and DHCP is residing on standard ports. So this PCAP file is considered to be normal based on our anomaly classification. Going forward with another PCAP file. So here the file field option is found to be overloaded, and the server field option is also found to be overloaded, and all the end options are found to be missing. So Let's look at how I came to this conclusion by going through the program. So here I've actually written or made use of regular expressions, and if the file field option or the server field options are overloaded, then their corresponding field names or field values will all be 0. So that particular comparison is done here and checked. So if the file field, just a minute. Yeah, so if the file field option is found to be 0 and the server field option is also found to be 0, then it could be a potential case of those options being overloaded. Similarly, the DHCP end option is also checked, and if it is equal to 255, then that means that the end option is possibly 0. So that particular conclusion is also displayed to the user, and the DHCP lifecycle is checked by seeing if the discover message, offer, request, and the acknowledgement messages are present in the given PCAP file. So that's about this. So going forward with another PCAP file for DHCP analysis, let's consider this. So yeah, here the DHCP lifecycle of discover, offer, request, and acknowledgement, they're found to be incomplete, and hence that particular conclusion is displayed to the user. So let's look at the PCAP file on Wireshark. So we can filter out all the DHCP packets by giving the following expression. So here we see that between a given source IP and the destination IP, the source IP is just sending the discover message and receiving the offer message. So it's not requesting the IP address after the offer message is received. So there's just discover and the offer messages in the DHCP protocol suite. So we can just see that here. So this is a possible indication that the DHCP protocol is incomplete, and that's the claim that we can make. So going forward with the next protocol family that is being examined in the project, let's look at DNS based anomaly detection. So DNS runs over the UDP service on port 53. So the first classification of detection is done to check if UDP traffic is running a service on port 53, but that service is not DNS. So that indicates a potential DNS exploit attack. And secondly, the given DNS query request is considered to be invalid if the source MAC address is found to be 0. And thirdly, denial of service attack is also detected if there are more than 5 DNS query requests to the same domain name, and when the server responds successfully with the IP address resolution for each query. So it's not that the server is not responding or resolving the IP address, but the server is sending out the IP address resolution, and the client is still flooding the server with the same DNS query requests again and again. So here 5 is a threshold that I have used in the project. You can include it to a higher or a lower value, any way that you find is satisfactory. And finally, port conformance is again done to check if DNS traffic is running on the standard port of 53. So let's look at executing the DNS based analysis by going over the first packet, sorry, PCAP file. So here the source MAC address is found to be 0, as we already saw, and hence the detection is done that the given DNS query request is invalid. Going about another PCAP file. So for this particular PCAP file, we find that there are too many queries for the same domain name, and this could overwhelm the DNS server, causing a possible denial of service attack. So we can confirm this by manually checking the PCAP file on Wireshark. So filtering out all the DNS traffic, we find that the given source IP address is making a DNS query request for the domain name lixhd.gnway.net many times, although it gets the response from the server for every request. So you can see it's repeatedly querying for the same domain name. So this again indicates a potential denial of service attack. So as you can see, I have appended all the query names and the domain names onto an array or a list, and here I'm checking for the same DNS domain name requests, and if that particular count is found to be more than 5, then that indicates a potential denial of service attack. Now let's analyze another PCAP file for DNS. So here DNS traffic is found to be residing on a non-standard port, and that conclusion is being made. Here, so if the given DNS traffic is not on port 53, then that means that it's a non-standard port for DNS traffic to reside on. So that's the conclusion that's made. And let's look at another PCAP file. So here the UDP traffic, the UDP service is seen to be executing another protocol or service on port 53 that's not DNS. So this could be a potential DNS exploit attack, whereby it's also causing a sort of denial of service and availability to the DNS server to be running on port 53. So that's the conclusion that we can draw from such PCAP files and packets. So that's about DNS based anomaly detection. Moving forward, because of the limitations in the data repository and the data sets that were found for the SMTP protocol, I resorted to checking for the port conformance to see if the SMTP traffic was residing on the standard ports of 25, 465, and 587. So here we're just checking if the SMTP service is running on standard ports or not. So going about executing the SMTP protocol, let's look at analyzing this particular PCAP file. So here SMTP traffic is found to be residing on the standard port. So there are no issues found in the given PCAP file. So coming to the future work, I'm planning to extend the given packet level analysis that I've done for the project to also capture and analyze live traffic. And I also plan to integrate the detection results that I've got by performing packet level analysis with firewall rules to create an integrated IDS and an IPS system in the network. And the most important part about this project was about going through different data sets and PCAP files initially to perform the outline of detection and anomaly report. And I made use of the following data repositories, which were great sources for a wide variety of PCAP files and web traffic. So malware traffic analysis.net was also a very good source for different puzzles relating to different malware families, and the email phishing attack was done and executed by getting the puzzle from malware traffic analysis.net. So that's about the project. I hope you like the project, and I hope it's useful to many people in some way or the other with respect to web traffic analysis. Thanks for stopping by. Bye.